Alright, to use the CBT machine, first we're going to come on to the computer. We log on with the password engineering. And we're going to open up these two files on the desktop. The first one is CBT main panel shortcut. The second one is CBT under. Open these up. Now this is ready. We're going to come over here and we're going to hook up the CBT machine to the pump. If the hoses are connected to the main cylinder on the press, first you're going to unplug those, and they are marked with a number. Hose 1 is going to be plugged into port 1 on the CBT cylinder. I'm just going to push that in and move the safety. Then we take hose 2 and we're going to plug that in to port 2 and move the safety. So now the hoses are plugged in. Next is the control system. We have two cables. Both are yellow for the CBT. The one marked with blue is for the proportional valve, and the one without a marking is for the relief valve. So first we'll do the proportional valve. We come down here to the punch proportional valve. It's marked with CBT in the same color. We're going to plug this in and tighten it. It's keyed, so it can only go in one direction. And this will control the position of the cylinder. Then we come in the back, the unmarked one. This is the proportional valve, the relief valve, and that controls the pressure in the cylinder. We want to run at about 400 psi for the CBT test. Next, we will turn on this thing. It's already on. That's the power for the data acquisition systems. And then we turn on the ball screw electrical panel. You'll hear a click once it's actually up and running. Takes usually a few seconds. It's up and good now. Then we're going to come to the CBT main panel code. We click the run arrow in the upper left-hand corner. This brings forward the pretest functions. Extend moves, or EXT moves the cylinder towards the electrical system, and retract, RET, moves the carriage towards the pump. If we click the home button, it will just go to the home position and we'll be ready to set up the test. So we click home, and this will move. Now it's in the home position. When we come back to the code, we're going to stop it and move to the next code, which is for the cylinder. We'll turn that on. And I just realized we forgot one more thing over here. We have to set the pump to go from the biaxial machine over here to the press and CBT machine by moving these into the right position. With that done, it changes the lines over so that when we run this, we're moving our machines and not that machine. Alright, so this is now in the home position. We're going to boot up the pump and move the cylinder crosshead into the correct position.
These are all aluminum.
So now it's on. Make sure you have the emergency stop switch. Over here, the CBT machine has no emergency safeties. They're all manually done. So if something goes wrong, you need to turn off the pump and turn off the electrical box for the ball screw. Otherwise, the machine doesn't know when to stop. So now the pump is on. We're going to bring up the pressure in the cylinder to 400 psi. You can hear a change in sound for the pump. Then we want the position to be at 140 millimeters. So I'm going to move this to extend. And the extend voltage is already set. It's a nonlinear voltage per proportional valve opening, so you'll have to play with that. Alright, so we overshot a little bit, so we move back to retract, bring it down a little bit, and we're good. So then, now the cylinder crosshead is in position where we want it to be, and we can put in our specimen. Come back here, bring the system back down to 0 psi, and stop. And then we can turn off the pump with the emergency button. So now the cylinder's in position, the carriage is in position. We can move back to the CBT main panel. So we have the CBT specimen. Once we set the carriage to the home position, lift up the rollers, and the cylinder's in the right position, we can load the specimen. The position of the specimen is determined by 1 inch from the center of the roller, might want to come around, to the shoulder of the specimen. So there's 1 inch center of the roller to the beginning of the edge where we would grip on to the specimen. So once it's there, that's where we'll start. And I'll tighten that up. Again, it's the opposite of lefty-righty. I mean lefty loosey, righty-tighty, when it's actually lefty-tighty, righty-loosey. I usually tighten down the first one pretty tight, so it grips on well into the material. The second one I don't tighten as hard because these grips actually come out when they tighten, so we actually put the specimen in compression. So then next guy is this one. Now that the specimen's locked in, I'm going to release the rollers, gently place them down, and now my caliper is set to the depth that's going to give us an equivalent depth into the material. So we want to go into the material 1.75 millimeters, which in this case corresponds to 31.17. Millimeters, and that's measured from the top of the roller support to the roller. So now what I'll do is I'll tighten this up by hand first, and I bring down the screws. You don't want to push down hard on the screws at the moment, because if they're not perfectly aligned, they'll actually push down further. I come back out, and I like to tighten the first screw that's going to actually have a pulling up action. That way, if I shift it, it's going to be pulled into these bolts, which will stop it. Whereas if I push down first, there's a chance it might move further down. So this guy's good. Go over to the other side, same thing. And it's too hard to do by my hands, so I'll use the wrench. And I go just until when it can slip in and I can move it. It's good. So there's a difference between the two. This one I use the side bolts to get it down because they're both free. this one, because there's tension, because this one's already down, I just manually crank it down to the right height and then I lock it in. Same idea, this bolt I pull up to tighten, so I'm going to do that one first, and then I'll do this one last. And now the specimen's in. The best thing to do is not have it sitting here for a long period of time, so you should be ready to jump into your test as soon as you're set up. So now what I'm going to do is come over here, turn on the pump, validate that my electrical box is on, which it is, make sure this area is clear. And I'm going to come to the CBT main panel, hit run. It's up and running. I have it set for now. Usually you'll run a test till failure, which is at 66 millimeters per second. I usually do about 60 cycles to make sure that I break that specimen. Usually the max we see is about 20 cycles. For this case, I'm going to put the velocity at 30 because we're not doing an actual CBT test. We'll do it for 4 cycles. Then over here, we can adjust the system pressure for the pump. I'm going to use 400 psi because that's what I've been using. You can also adjust the retract voltage. This is V for voltage, not for velocity, but that corresponds to a certain crosshead velocity. I have a collection of what those are and some other documents. So if we're ready to go, we hit the home button. That stops the pretest functions. By hitting start, we begin the test. The rollers will start moving, and then we need to move here after 1 full cycle to activate the cylinder. So for this part, you might want to back up. Alright, there we go. So now I'm starting the cylinder. So now the cylinder's on. The test is going back and forth. We're almost done with the total number of cycles that I want to run. So then, once it stops, you have to stop the cylinder on the screen. And then you can kill it with the emergency switch. And the test is complete. So I'm loosening the specimen. Normally this process would be a little different because the specimen would fail. I'm also going to loosen these, bring up the rollers. When the specimen fails, and the number of cycles is not complete, you need to manually stop the CBT test by hitting the emergency stop button on the NOOK electrical box. You push it, this carriage comes to an immediate stop. You can then turn this to the off position, come in here and say stop, and also stop the cylinder. Then I'll show you where that file is located after I get this situated. So again, we're loosening the setup. Normally this wouldn't be as complicated because the specimen had broke. And the tension would be relieved on this part. So now we're going righty-loosey. The specimen just released. This side. Now the specimen's out. Watch these teeth. Sometimes they slide out and they'll hit and dent and chip the paint. So have your hands there to catch them. Specimens normally be labeled and marked, but we don't need any more. So I'm just putting in the strap. So we can go back here. On the desktop, there's a file called CBT data. And in this file is where our CBT test data comes. So right now they're labeled CBT. If I ran the test a second time, it would be CBT_1. What I normally do is I'd rename it to whatever our particular test was. So this was just a test. If you open it, there's several columns of data. These columns are then listed out in detail after all the columns. So like the first one's the time in seconds, the next one's the ball screw velocity. At the end is the main information, which is the 2 load cells and the cylinder position. You can copy this file into an Excel document and clean it up from there. If you, for some reason, you want to see the data from the cylinder positioning test, say if you want to just do a simple tension test, you can go to tension test, and it has all the data files from moving the cylinder into position, or if you have a specific test. And I believe that is it. Good.